So Pydantic just released their agent framework, and in this video I'll share everything that you need to know. I will be walking you through this GitHub repository that I will also make available for you. Of course, we'll dive into some practical code examples so that by the end of this video you should have all the information you need in order to decide whether PydanticAI is something that you could fit into your stack when you are building apps with LLMs. And now, if you're new to the channel, welcome. My name is Dave Ebbelaar. I'm the founder of Datalumina, and I've been building custom data and AI solutions for the past 5 years. We also have our own AI SaaS where we integrate LLMs. And on this channel, I share videos to help you do the same. So in order to follow along, you can clone the repository. Link is in the description. And here in the README file, we also have additional resources that you can check out. Now, before we dive into the code examples, I want to start with a little bit of context of how PydanticAI works, because otherwise the code probably doesn't make a lot of sense. Now, I will also link the official documentation for where you can dive deeper into some of the core functionality and also, of course, the API reference. So the goal of this framework, this library, is to help you build more robust applications around the use of large language models. There are tons of frameworks out there already, but almost all of them leverage Pydantic under the hood when they're working with structured output. So this is the instructor library. Now OpenAI is doing that as well. We have, of course, Langchain and Llama Index. And seeing an official framework from the creators behind Pydantic, to me, is really exciting. I'm normally very hesitant with diving into new frameworks because, to be honest, I think most of the frameworks out there are way too complex and you probably don't need them. But I wanted to find out if PydanticAI offers some kind of like low levels abstractions that I could actually use in my projects. Now, why would you want to use PydanticAI? And this is from the official documentation. Now, first of all, it's from the team behind Pydantic. And this is a strong argument since all of these other libraries and frameworks out there are also leveraging Pydantic. Model agnostic, meaning that you can use different model providers. They have a couple supported already, working on more. It offers type safety, control flow and agent composition done in plain pure Python. They have structured response, streamed responses, and a novel type-safe dependency injection system. This one is really interesting. And finally, they have an integration with Logfire. So this is something the Pydantic team is also working on behind the scenes. I haven't used it, but it's similar to what Langsmith and Langfuse can do. So looking at this first glance, it seems to be very similar to what other agent frameworks are providing, right? So if we look at the core concepts, we have our agents, dependencies, results, message and chat history, testing and evals, debugging, and monitoring. So all things that you could also do in Langchain, Llama Index, AutoGPT, Crew AI, Instructor, and many more. So the real question then becomes, so why would you want to use PydanticAI over, for example, Langchain, Llama Index, or the Instructor library? That's also one of the goals of this video, and by the end we'll have all the answers for that. So whenever you're diving into a new framework, the first and most important thing is always trying to understand the philosophy behind it and also look at the core components that work together. Now, for this tutorial, we'll be focusing on agents, dependencies, results, and the messages and chat history. Testing and evals, debugging, monitoring will be out of scope for this video. So we're going to look at how to chain all of these things together and tie them together in order to take our data, send it to OpenAI in this case, send it to an LLM, and then get structured responses back. All right, so let's jump into the code base and start with this quick hello world example to show you the very minimum of how to work with this framework. Now, 2 notes over here. I am going to be running this code in the interactive Python session that you see over here. If you want to learn more about this approach, check the link in the description. And because some of the code that we will be running is going to be async, I'm going to import the nest_asyncio and run this command over here. This is just to make it work in a Jupyter environment. This is not something that I would recommend in production environments. It's just for an example. All right, and then let's start with the most important thing of working with LLMs. Let's pick our model. So for this, I'm going to import the OpenAI model class and I'm going to specify GPT-4o. So this is now our model. Now, there are 2 ways in PydanticAI that to select models. So a model is always passed to an agent, which you can see over here. So we're going to set up a basic agent. So this is one approach, but you can also do it the following. So here, this is from the documentation. You can also specify the model by saying we use OpenAI and then specify which model. I like to have this more specific over here and also so that we can reuse it. So I'm going to proceed using this method within this tutorial. Okay, so we've specified our model. So now let's see how we can make this model available to an agent. So let's look at this agent class and look at what it is. So it is essentially a container for a system prompt, potentially tools, the types of results in the form of structured output that we want to get out of it, potential dependencies, and an LLM model. So we can store all of this information in the agent class and then start working with it. But really at the bare minimum, we need a model and we need a system prompt. So here you can see we have a basic prompt, helpful customer support agent. All right, so let's run this code. We now have our basic agent, and the next step would be running this agent. And now there are 3 ways to do this. We can call the agent.run, which will do it async. We have the agent.run sync, which will do it synchronous. And we have the agent run stream, which is useful for streaming responses. So throughout these examples, I will be using the run sync just to keep it easy. But what we can now do is we can run this response. We get the result back from the agent. And in here is a lot of information. There is also an entire page over here to learn more about this result object. But it's the result from running an agent, and the values are wrapped in the results, the stream results, and we also get things like the costs and also the message history. So with this object now in place, what we can do is, for example, look at the data that's in here. So we can call response.printData, and we can see the reply from the LLM. So it's saying to track your order, please check the confirmation email we sent to you. So it is making up an answer over here to reply to this customer. But we can also have a look at, for example, all the messages that are in here. So I can print this, but we can also have a look at the list over here. So you can see we have the system prompt in here, which is the one that we started with at the agent. Then we had the user prompt, that is what we sent to the LLM. And then we also have the reply from the model in the form of the content over here. So we have the whole scope and all of this information within this response model. And we can even look at the cost over here, where we can have a look at all of the tokens. And now if we, for example, wanted to continue the conversation, we could run the agent one more time and pass in the message history, where we just look at all of the previous messages and then, for example, ask, what was my previous question? Get the data out of it. And then your previous question was about tracking your order. Okay, so very simple example of how this works, but also nothing that you can do with just the bare OpenAI API, right? So let's look at how we can actually integrate Pydantic in here and start to work with structured output. So for this, we're going to create a new Pydantic model that we inherit from the base model, and we call it the response model. So instead of just asking the LLM, give us an answer, we're going to clearly state, if you give us an answer, we want the following schema. And we want to get this back in a structured way so that we can load it into this response model, and Pydantic will then validate that for us. And now here we have the same agent, but now we also specify the result type, which we set equal to the response model. So this is similar to how you work with the instructor library or with getting structured output directly from OpenAI using a Pydantic model. So let's load that agent up and run this one more time. So we run this and then we get the response back. And now the response is going to be that run result again. But now if we look at that response.data, but instead of just having the text in here, so the content, we now have an actual Pydantic model called the response model. So what we can now do with this is we can also model dump this to JSON, put some indents in here, and we can have a look at everything that the AI came up with. So we have the response that we can send back, whether it needs escalation, follow-up, and sentiment. So this is already a step up, but again, nothing that you cannot do with the other libraries out there. Then before we dive into example number 3, real quick, I want to tell you a little bit more about how we help developers like you beyond these videos here on YouTube. With Datalumina, we have all kinds of resources for free and also higher level programs for learners, students, freelancers, and businesses. So make sure to check out the links in the description. So now let's go one step further and look at Agent 3 over here, another example where we're not only going to get structured output from the model, but also we're going to inject some dependencies. And this is really where it gets interesting. They say they have a novel type-safe dependency injection system. And now, while I'm sure some of the other frameworks out there also support something like this, I have never seen it implemented in such a simple and elegant way as I see over here. And this is also something that I built from scratch and use in all of our projects, because with LLMs, it's not only structuring the output that you want to get back from the model, but you also really want to validate the input, because you always need to send some data to an LLM and you also want to validate that. And that is where the dependencies can come in. So in this example, what I did is I defined two Pydantic models. So we have a customer over here, which has an ID, name, email, and also some orders. And the orders is a list of another Pydantic model. And by the way, if you're new to Pydantic, make sure to do a quick refresher on it, do a quick tutorial so you understand that, because that is really at the core over here. So a customer can have multiple orders and they are in this Pydantic schema over here. So now here we have agent 3. And now next to specifying the model, the result type, we also specify the dependency type. And we set this equal to the customer details. And what we can do with this is we can add those details to the system prompt and essentially make it available as context for the large language model. And by setting it as a dependency and having it in a Pydantic model, we can also validate that. So that is going to be really interesting. So let's see how that works. I'm going to quickly run this. We have a system prompt over here. So this is essentially information that is known when writing the code. So these are the prompts that you can structure. But now when we look at a dependency, if you, for example, think about a customer care ticketing system, you can specify all the information and prompts about how your company works. But then when a new client comes in with a question, of course, that client or customer information is specific, and we need to load that at runtime. So we can add dynamic system prompts based on these dependencies. And you do that with the following syntax. We are going to reference the agent over here, agent 3. We're going to use the @ symbol to create a decorator, and we call the .system prompt. Now we're going to specify an async function over here, and you can name this whatever. In this case, we're going to call it @customer_name. And we are going to add the run context in here. So this syntax is a little tricky at first. You have to look into this. You can also read through the docs with the agents and the dependencies on how this works. But essentially what we do is we import the run context from PydanticAI. So this is core functionality of the PydanticAI library. Then we plug in the customer details. That is the model that we have specified over here. And then we essentially say what we want to do with this. And we just return a string saying the customer details is, and I have a function over here to convert a Pydantic model to Markdown, because that tends to work better for the models from OpenAI. You can have a look at it. It's in the utility folder over here. But you could, for example, also do a JSON dump. But what this will do, it will just take the Pydantic model, convert it to Markdown. And we take the context and then the dependencies. So this is the syntax on how to inject that dependency. So let's run all of this so we can have a better look at what's going on. Let's specify a customer over here. So now first we just defined the customer details model. For the agent, we specify that it depends on these customer details. And now here is a new request coming in from this customer, John Doe. So we have all of the information in there and we have a dummy order. And now here what we can do is with our agent 3, we can run it and we can provide the user prompt. And now next, we're also going to put in the dependency, which is going to be set equal to the customer. So now let's run this and let's have a look at the responses to see what's going on over here. What you can see right now here is that all of a sudden we have two system prompts. So next to the original system prompt that we specified within the model, we have provided the model with the following customer details. And here you can see that toMarkdown function in action. So you can see it is using the hashtags and it's using new lines in order to display all of that information and then also the orders. So we have now provided the AI system with that. And then finally, if we have a look at the response, we can see, hello, John, you ordered the following items. So John just asks, what did I order? It's not in the system prompt, but through that dependency, we were able to plug that in. Now, the cool thing here is that since this is all using Pydantic, what we can, for example, do is, let's say the customer ID comes in and it is an integer instead of a string, even though we have specified that the customer ID should be a string. So let's now say you are integrating with various ticketing systems or webhooks and data is coming in and we try to run this. Now we get a validation error in here and your system will not run and you will be pointed at the error. So essentially what we do with this, we ensure that every time we run agent 3, we are very certain that we have the right information and the right context that this system needs in order to work with this specific system prompt and this context information. So let me put it back and run it one more time. So we can get all the messages, we have the response, and now we can also use this print statement over here to see, okay, we have the name, the email, we have the response, and also the status over here. Now this, what you're seeing over here, is really the key to building production-ready AI systems. You want to very strictly validate your incoming data, make sure you have all the right information. Then you want to pass that to an LLM using well thought out system prompts, and then you want to force that LLM to provide you with structured output that you can then use within your control flow. Because now you can see needs escalation is set to false, follow-up required is set to false. Now, depending on how you design your system, you might now want to directly send this message back to the customer because there's no follow-up required and no escalation needed. So that would be a good message. But if there is, for example, follow-up required, you might want to escalate it to a human agent who can then, for example, send the message and then looks up some information, or if it's some kind of like weird message or something that the AI cannot help with, directly escalate it to an agent, to a real human agent. So as you can see, this is a simple example for customer care. It's something that we've been doing a lot of work in, and I think it's an example that a lot of people can understand. But you can extrapolate this to any kind of system that you're building with LLMs where you have to control the flow of your application and get to that desired output that you want to send back to the user or store in the system. So this, in my opinion, is a really good feature of PydanticAI, being able to specify these dependencies details at the agent level. All right, and then next, let's get into example number 4, which is how to use tools. So agents can also use tools. So here we'll look at how we can register those tools and also how we can access those tools. So tools in the context of agent systems are various methods, functions that the AI can decide to use and then provide you back with structured output for you then to be able to use that structured output within your code, within the functions to, for example, retrieve information. And in this context, we're going to look at an example where we're going to call some kind of API or database where we can get some information on the shipping status. So I have a very simple example over here. Normally, of course, this would not be in your code base, but would be an external service that you call via an API. But in this case, it's a simple dictionary. So we're going to primarily look at this order number 12345 with the current shipping information. And in order to work with tools, we first need to register them. And there are 2 ways to register tools and 2 types of tools. So let's start with the types of tools first, and that is tool and tool plain. Tool you use when the tool needs to access context from the agent, and tool plain is when you don't need context from the agent. Now, in most cases, you will be working with this one that requires the agent information. Then also registering your tool. So there are 2 ways to do it. So you can use the decorator that is shown over here. So again, you can specify your function, which is the tool, the logic that you need. And then you can use the decorator to essentially add it to the agent. But you can also use the following notation, which I will show over here. So you can also just provide the agent with a list of tools. two ways to do it. I will show both. First, we do it this, and then in the last example number 5, we do it via the decorators. So here we have our tool, which is a simple function that requires the context, and that is the run context where we plug in the customer details. This is going to output a string, and it's going to do that by taking the shipping info DB database over here, which is a Python dictionary, and we're going to do a lookup by accessing the key over here. And we're getting the key from the context.dependencies.orders, and then we take the first order, and then we take the order ID. So again, let's remember the customer details that we've specified, right? So this is going to be the context. So that is context.dependencies. Then that is this customer details model. Then we can call the orders with .orders, and then in here we have the order ID. So that's the syntax in order to then get to that final number that we can look up in the shipping info DB. So that's how that tool works. And like I've said, we're going to make it available already at the agent level here instead of using the decorators. So now let's run agent 4 over here, initialize it, and again add that system prompt. So this is the same one we already covered by adding the customer details to the system prompt, so it has context on who that customer is. And now we're going to run agent 4, and let's wait for these results and look at the context over here. So here we can see all of the messages that are included. So we have the original system prompt, then the system prompt that we added with customer details, the user prompt. Then here we have another step where they decided to call the tool name getShippingInfo. So this was the goal, right? We provided with that information. It saw that the user was asking status of last order, and then the AI thought, okay, this would be a good time to call the getShippingInfo method. You can then here see that it returned the content shipped on 1st of December. And then finally, we get back the message over here that we can then send back to the customer, which we can also print over here. Hello, John, your last order, here's the ID, was shipped on 1st of December. So here you can see that now we are combining lots of different elements. So we have a system prompt to control the LLM. We take the user information and provide it as a dependency in the form of the customer details model. And we also even get shipping information using a tool. So now we're really pulling information from all kinds of places, but doing it in a very controllable and structured way. And now you can really see how this could come together in a fully working system. And now in the final example here, number 5, I want to show you how we can bring all of this together and even add reflection and self-correction. So this is a very powerful concept where if the AI runs into some kind of error, either through validation or data that it has to look up, we can even specify it with instruction on how to self-correct, which will then be sent back to the LLM for it to reflect on, which can sometimes help you to correct a JSON schema, for example. So let's look at how this works. And we're going to use that same shipping info DB, but now instead I have made it so that in the database, the order numbers are actually, they start with a hashtag. And we don't have this within the data. So within the data coming in, there's an error. And because of that, we can't look up the data. So let's see what that looks like. We have the database, and then let's look at the customer details. And for this one, so I create a new customer details and I leave out the orders. So there's no order information in here. So we also really force the model to use that tool and access that information. So here, nothing has changed. It's still the same agent, even though we call it agent 5. Same setup as we already covered. But now what we're going to do is we're going to add a retry mechanism to our tool. So here you can now see that we're using the decorator to register our tool. And here you can see we're also using a tool plain, which means that we're not going to use the dependency context that we have specified. In this case, we're just going to extract the order ID from what the customer is asking and use that rather than the dependency. Now, what we're doing over here is we try to get the shipping information from the DB by using the get order. So this is going to perform the lookup. And now if the shipping status is none, meaning that this returns an empty result, we're going to raise the model retry. And the model retry is another class that we import from PydanticAI. So what we can do with model retry, coming all the way over here, we can plug a string in here with specific instructions. So we can define different rules on where common errors might occur within our system and then give specific prompts. So for example, if this is a common problem where customers, for example, ask for the status on their order number, but it is required to plug in that hashtag, and then, for example, customers don't include that. Now, this is something that you probably wanna tackle in a more clever way than doing it like this, but it's just to show you the capabilities of how you could use such a retry mechanism. So I can now register that tool. So Agent 5 will now have access to this tool, and we can run this query over here where the customer asks, what's the status of my last order 1, 2, 3, 4, 5? So let's run this, and what's happening behind the scenes is that Agent 5 should now view this request. It should look at the system prompt, then it's going to plug in the customer details as another prompt, and it's going to review this question. It then identifies, okay, I don't have access to that order information, but I do have access to this tool called Get Shipping Status. This is probably what I need to do. But now, because we registered this as a plain tool and it doesn't depend on the context of the customer, because maybe we don't have that beforehand and we really have to ask that from the customer, this now just takes a plain order ID string that we need to extract from the customer question. And now if we look at the results over here, you can see the same structure as usual, but there is also a retry prompt over here, where it is saying no information found for this order, make sure that the order ID, etc. And that is exactly what we plugged in over here. So now you can see you should really view this as the whole conversation with OpenAI. And because we raised this model retry, it's going to rerun it, but now it has, the second time it runs it, it has that retry prompt information in there, and it's going to self-correct, and then it knows, okay, that order ID, it doesn't need to be the 1, 2, 3, 4, 5, but it needs to be hashtag 1, 2, 3, 4, 5. So it's going to update that. It's going to call the get shipping info DB again. It's going to retrieve a result, and now it's going to provide that, or it's going to return that result because it's not going to enter this if statement. So that's how you can introduce reflection and self-correction into your LLM systems. And now you can control this with the retries parameter, which is set to 3 in this case. And you can control the model retry at various levels. So you can do it for the entire agent at a specific tool or a result validator. So again, granular control over, so for example, here we set it just at the agent level, but you can also set it at the tool level. So that's how you use PydanticAI. Now I'll give you my review so far, and I like what I've seen, but we also gotta acknowledge that this is a very, very early beta version of PydanticAI and their API, so things are likely going to change. I would be hesitant to, for example, look at our production applications right now and introduce this just because of all these changes. I've had this in the past with other frameworks, Langchain being the most problematic, where I've promised me and the team to stay away from all of that. So I'm really careful with that. But that said, I do think this has a lot of potential, because what I really like about this is that they apply that Pydantic mindset of validating all your data and bringing that to the world of AI agents, which is so important. And instead of trying to solve all the problems that you have around building agent systems, basically what this now is focusing on is, okay, how can I structure all of the inputs and outputs in a way that I can make them available for the LLMs? And that I very much like. And that would also be a framework that I would be confident to use if it tries to stay niche and specific on top of that. So I really like how it is currently very lean, low-level abstraction around these APIs, where you still have a very good idea of what's going on. With some of these other frameworks, Langchain in particular, all of the inherited classes and functions are like 3-4 levels or layers deep, where if you really dig down into the code, you have essentially no idea what's going on. At least that's my take on it. With this, I still had a really good overview of what I was doing and what my code was doing. That said, I did already run into some things where I felt like, okay, it's a little bit weird. So one of the most prominent things, and maybe I've completely missed this, let me know if so, but I can change model parameters. So even something as simple as changing the temperature, I couldn't find it. Maybe it's in there, but let me know. And also one of the things that I had when, for example, using the message history when using tools was also resulting in errors for me. Now, these are all things that will likely be patched in the very soon once people start to use this and give their feedback. But now, like I've said, it's an early framework. I would be hesitant to use this in serious applications, but I think they're onto something here, and this could have the potential to be really one of the major players within the space of agent frameworks. For now, what I would recommend, and this is also what I do with all of these frameworks out there, try them out, see what you like, and try to take specific elements and introduce it into your own stack. So, for example, the dependency injection that they are working with, I really like that concept. It's something we're already doing for our projects, and we're using we're using the instructor library to get structured outputs from LLMs. So combining those two ideas together works really well. So we stay within that Pydantic ecosystem. So I think that's one of the biggest tips that I can give you when it comes to working with all of these new tools and frameworks and things that come out. Experiment with them, learn from them, see what you like, but don't try to become over-dependent on a particular framework, because now you have an extra dependency within your project, and every time something changes or you want to change something, it can be annoying and it can just result to a lot of technical debt within your project. And this was actually also an interesting discussion point that I had this Tuesday in our Data Freelancer community call, where we talked about PydanticAI, and then one of the members asked my opinion, and also from the group about opinion on all of these frameworks and what we use. And we basically built something from scratch, very low level in pure Python. That's what we use, but I essentially explained what I just mentioned to you, right? Don't want to become over independent. You can probably do it yourself. You might not need a framework. And then one of our other members gave a very interesting argument about tools versus solutions, where a lot of these libraries and frameworks that are listed over here are really like full solutions. So, for example, Langchain, Llama Index, they thought about everything. Everything that you could potentially do with an LLM, they have some kind of like method and class for it. And if you use their ecosystem, it works really well. But if you want to try and combine different things and change things, so using it as a tool, then it's going to be problematic. So they work really good as is, as a solution. But if you want to build really robust applications where you fully have a complete understanding of what's going on, you rather want to look at different tools that you can use and introduce into your project. And I feel like PydanticAI right now leans more towards being a tool that you can use rather than an entire ecosystem. But I'm also curious, let me know in the comments, what's your favorite approach to building system with LLMs? Do you use Langchain, Llama Index, another framework? Or did you build something from scratch like we did? Let me know down in the comments. All right, and then that's it for this video. Now then, if you're a developer that's also building systems with LLMs and you want to do this to start your own business or maybe grow your own business, then you might want to check out the first link in the description. It's a video of me going over how my company can help you with this. We have a community called Data Freelancer where we unite freelancers and developers from all over the world who are building data and AI applications. So if you're interested in that, go check it out. And then I want to thank you as always for watching. If you found this video helpful, please leave a like and also consider subscribing. And then next, if you want to learn more about how we at Datalumina find, deliver, and also build these AI applications for all of our clients, make sure to check out this video next.